Hello, welcome back to Mini Education. In today's topic, we are starting a new chapter that is mechanical properties of solids. In mechanical properties of solids, we are studying about what will happen if you apply a force to an object. Let us, in the case of solids, solid has a rigid body. It is one type of matter. Okay, matter consists of atoms and molecules. Matter, it exists in three states. Already we know, that is solid state, liquid state and gaseous state. Okay, in a solid, each atom or molecule is associated by neighboring atoms. These are bonded together by intra-atomic force and stay in a stable equilibrium position. Okay guys, in this chapter we will discuss the elastic properties of solids. Okay, a solid has a definite shape and size. In order to change the shape or size of a body, a force is required. Okay, suppose if you stretch a spring for this is spring. If you stretch a spring by gently pulling its end, the length of the spring increases slightly. When you leaving the ends of the spring, okay, it regains its original shape and size. Here elasticity can be seen. Here elasticity can be seen. Elasticity means the property of a body by virtue of which it tends to regain its original shape and size after the removal of applied force is called elasticity. Here we consider three forces, that is applied force, and restored force and deforming force. Here deforming force means the force which when applied changes the dimensional configuration of the body is called as deforming force. Okay, and next, plasticity. We discuss about plasticity. In plasticity, the property of a body which does not regain its original configuration to all the removal of deforming force. But elasticity, it regains its original shape and size. But plasticity does not regain its original shape and size. Suppose if you applied force to a clay, okay, they have not to regain their previous shape and they get permanently deformed. It cannot regain their original shape. Okay, here dung and clay are close to ideal plastics. Okay, in elastic behaviors of solids, elastic behavior of solids, the restoring mechanism can be visualized by taking a model of spring ball system. Shown in the figure, the spring ball method for the illusion of elastic behavior of solids. Here, the balls represents atoms, and the spring represents intra-atomic forces. Okay, if you try to displace any ball from its equilibrium position, the spring system tries to restore the ball back to its original position. Thus, elastic behavior of solids can be explained in terms of microscopic nature of the solids. Okay, this is the best example of elastic behavior of solids. Now we are going to study about what is meant by stress and strain. Stress. Stress means force per area. Force per area. The perpendicular force acting per unit area is known as stress. Stress are many types. One is longitudinal stress. Longitudinal stress. Longitudinal stress. It is a lengthwise stress. Force acting per unit area in lengthwise is known as longitudinal stress. Here two types are there. One is compressive and another one is tensile. Compressive stress means length decremented stress is known as compressive stress, and length incremented stress are tensile stress. And the another stress is volume stress. Volume stress. And the third stress is tangential stress. Tangential stress will be called otherwise known as shearing stress. If you are applied an force in tangentially, here angle wise slight incremented will be happening. Okay, here the restoring force per unit area developed due to the applied tangential force is known as shearing stress. Okay, stress means force per area. It has three types: longitudinal stress, volume stress, and tangential stress. Longitudinal stress are two types: compressive and tangential. Okay, the units of stress is Newton per meter square or Pascal. Its dimension is m L to the power minus 1 to T to the power minus 2. Okay, the dimension of stress is m L to the power 1 and T to the power minus 2. Okay, next strain. Okay, strain means change in dimension by original dimension. It has no units and dimensions. It is of three types. One is longitudinal strain. Longitudinal strain means change in length by original length. It is known as longitudinal strain. And the second one is volumetric strain. It means volumetric strain. It means change in volume by original volume. The third one is shearing strain. Shearing strain will be the angle how much that's increased. That increment is known as tan theta. Here theta is the angle of inclination. Tan theta is known as shearing strain. See, suppose the object here. This is the object. Suppose the object here. Okay, and I am applying a force having length L. I am applying a force F, length L. This is also length L. That what does happening? This will be going to this direction. If it is B means delta B. It was increased. Delta B, it was increased. Okay, so that means it making an angle theta. Making an angle theta. This tan theta angle is known as shearing strain. Okay. And also that shearing strain means change in length of the uppermost layer of the object delta x to the thickness of the object edge is known as shearing strain. Okay, the next important topic is Hooke's law. Before studying about Hooke's law, you should learn about another term called the elastic limit. Elastic limit. Elastic limit. See, I am considering an object that is rubber band. I am applying a force and releasing. What will happen? It will come back to the original position, and again I am applying a force, coming back, and repeated in many times. What will happen? It will extend it in original shape, like applying many times the force, it will extend in particular way. It's increasing in length, permanently extending within the elastic limit. Here elastic limit is the body lost its property of elasticity and gets permanently deformed. According to this law, within the elastic limits, the stress is directly proportional to strain. Okay, stress here. Stress is directly proportional to strain. So stress is equal to into strain. Here where E is constant of proportionality, that is called modulus of elasticity. Modulus of elasticity. The modulus of elasticity we discussed on further video. Okay, then next, Hooke's law is valid only in the linear part of stress strain curve. Stress and strain curve. In a stress strain curve, we are considering a graph. In y-axis represents stress and x-axis represents strain. X-axis represents strain. Its sigma represents the stress. Okay. From the graph, you can see that in the region between 0 to A, the curve is linear. In this region, Hooke's law is obeyed. The body regains its original dimensions when the applied force is removed. In this region, solid behaves as an elastic body. In this region, the solid behaves as an elastic body. In the region from A to B, stress and strain are not proportional. And the body still returns to its original dimension. When the load is removed, the point B in the curve is known as yield point. The point B is known as yield point, also known as elastic limit. Okay, and the corresponding stress is known as yield strength, that is yield strength. It is represented by sigma y. If the load is increased further, the stress developed exceeds the yield strength and strain increases rapidly, even for a small change in the stress. Okay, the portion of the curve between B and D, B and D shows this. When the load is removed, say at some point C between B and D, the body does not regain its original dimensions. In this case, when the stress is zero, the strain is not zero. That material is said to be have a permanent set. This material is said to be have a permanent set. This is O dash. This set is known as permanent set. Okay. The deformation is said to be plastic deformation. Okay, the point D on the graph. The point D on the graph is the ultimate tensile strength. Ultimate tensile strength sigma y. This is the ultimate tensile strength. Tensile strength. Ultimate tensile strength. Okay, beyond this point, the additional strain is produced even by a reduced applied force, and fraction occurs at point E. Fraction occurs at point E. If the ultimate strength and the fraction point are close, here D is the ultimate tensile strength, E is the fraction point, are close, the material is said to be brittle. Okay, if they are far apart, the material is said to be as ductile. Okay, here brittle means it will break fast, and ductile means it will take time. Okay guys, the stress strain curve varies from material to material. Okay, right guys, thank you for watching this video, and now please subscribe, share and like.